differential equation. So on our last tutorial we couldn't quite complete classification of differential equation. So now I want to see classification of differential equation. Now basically there are two classification of differential equation. We have the linear differential equation and the non-linear differential equation. So now let's talk about the linear differential equation. Now what is a linear differential equation? This is an equation in which the dependent variable y and its derivative appear in additive combination to their first power. Now, what is this just trying to say? The dependent variable. Now, what is dependent variable? For given a function y is equals to fx, this is your dependent variable and this is your independent variable. So, an equation in which whereby this dependent variable will be added to the derivative of this same dependent variable to their first power. That means the dependent variable in every linear equation must have a power of 1. So for example, let's take for example before I explain this general form. Now, a linear differential equation in which the dependent variable must be in additive combination. It must be added or it must be combined to the derivative of this differential equation. Okay, let's take for example y plus dy dx is equals to 2x. Now this is a linear differential equation. Why? Because we're having a dependent variable which is added to the derivative of, remember this is dy dx, derivative of y with respect to x added to its derivative with respect to an independent variable, and it is equal to a function of x. Now, following the general rule, looking at this general rule now, this is a derivative of y with respect to x, following from order of n to 1. Now, this is technically the highest order of this differential equation. Okay, now that is not our main goal. Our main goal is identifying a linear differential equation. So looking at this equation now, what is a linear differential equation? So interpreting this general form, we're having a coefficient of x, coefficient of x multiplying their derivative of y with respect to x. Now getting to this point too, we're having y. Now from if you look at this, these are derivative of y with respect to x. Then we have just a dependent variable here equating a function of x. So what will tell you that a linear differential equation must surely have derivative of dependent variable with respect to independent variable, and those derivatives must be multiplied by coefficients of x, and also the independent variable must be of power of 1. Any equation that the independent variable is not of power of 1 is not a linear differential equation. Now looking at this equation, looking back to this equation now, you see that the dependent variable y is of power of 1 and is added to it and is having a derivative equating. Now if you look at this general form of equation, is equating a function of x. So the same thing with this my equation, equating to x, which is also a function of x. So I can say for identifying a linear differential equation, 1, the dependent variable must be of first power. So this is the first condition. The dependent variable must be of first power. Now if you look at, let's take a look at this equation. Y square plus d square y dx square equals to 3x. Now look at this equation very well. This is technically not a linear differential equation. Why? Because the dependent variable y is not of first power. Here the dependent variable y is of what? Second power. So that's the first condition of identifying a linear differential equation. Now the second condition of identifying the linear equation is that its derivative must be multiplied by coefficients of x. So The second condition of identifying the linear differential equation is that its derivative must be multiplied by coefficient of x. Now looking at this general form, you see that every derivative here of y with respect to x are multiplied by coefficient of x. This is an minus 1 coefficient of x, coefficient of x. Even the dependent variable itself is multiplied by what? Coefficient of x. So every linear differential equation, the derivative and also the dependent variable must be multiplied by what? Coefficient of x. Now let's take for example. This equation y dy dx plus d square y dx square equals to 3x. Let's take this first equation. Let's take the second equation. X d square y dx square plus y equals to 5x. Now looking at this first equation, let's start with this one. Looking at this second equation, this is actually following our linear differential equation general form. Because why is it following our linear differential equation general form? Because our general form says that the derivative must be multiplied by coefficients of x. These are coefficients of x, coefficient of x, coefficient of x. So if you're looking at this particular equation, you see that this derivative here is multiplied by what? A coefficient of what? X. And also the dependent variable is of what? First power. So I can definitely say this is a linear differential equation. Now looking at this first equation, you see that what is multiplying this derivative, it is not a function of x, it's a function of y. So definitely this alone has already rendered this equation non-linear. So these are just the two basic conditions of identifying a linear differential equation. So we can basically say a non-linear differential equation is an equation that in which the dependent variable y and its derivative are in additive combination, not necessarily to their first power. So now let's take two more examples for us to get familiar with identifying linear differential equation and non-linear differential equation. Let's take this example. Y squared plus x squared dy dx equals to x. Now looking at this equation, is it a non-linear differential equation or a linear differential equation? How do you know? You look at the dependent variable. Here the dependent variable is not of first power, is of what? Power of 2. So this renders it non-linear. Let's take another example. Dy dx plus 1 over y equals x plus 3. Now, looking at this particular equation, looking at this second equation, we have the derivative of y with respect to x, yes, in additive combination. Now, it is not in additive combination to the dependent variable of first power. Now, what is the power of y here? We're writing this in index form. This is 1 over y raised to power 1. So you see that this here is not of first power. Instead, it's of what? Is an inverse power. So you get, so this renders it what? Non-linear. I'm getting it now. So let's take a third example. This is x square dx square plus y raised to power 3 over 4 equals 3x. Now looking at this also, this is not a linear differential equation. Why? Because the dependent variable here is not of first power. So if you have an equation that the dependent variable is not of first power, makes it non-linear. So are you getting me now? So that is that. So this is just all about identifying linear differential equation and non-linear differential equation. Like we said, to sum it up, to identify an equation will be linear if the dependent variable is of first power and the derivative must multiply by coefficient of what? X. Thank you.